Hey, Pikachu, I'm kind of confused about derivatives. I had to learn about them for calc, but I'm not really sure what they mean. Do you understand? I'm not really sure. I don't know. I'm not sure either. I wonder if there's somebody who could teach us.
I can teach you about derivatives. Derivatives are written in terms of d over dx. They represent the slope of a function and can also be used to determine a velocity.
Alright, now that we know what derivatives are, let's try a problem. Here I'll break it up into 3 parts, so that way we can see what to do with each derivative. Over here for x squared, what we're going to do is that we're going to take the exponent and we're going to put it in front. So it's going to turn into 2x. And we're going to take the and we're going to subtract 1 from the exponent that was with the x. So 2 minus 1 is 1. So we're going to just leave it at x. And then for the next part, which is 6x, what we're going to do is we're going to carry the sign, so it's still going to be plus, and then we're going to take, like how we did before, we're going to take the exponent and multiply it to the first number. But because the exponent is 1, we're just going to take away the x. So instead of 6x, it'll be 6. And then with 10, because it doesn't have any x's, it's just going to become a 0. So the derivative for this, so 10 is just going to disappear, kind of. And then because of that, the whole function is going to be, for the derivative, it's going to be 2x plus 6.
So now we're going to try a harder problem. First, I'm going to isolate 3x plus 4. I'm going to bring my exponent down and multiply it by the coefficient, so I get 12x. Now I'm going to subtract 1 from my exponent, which gives me 12x to the 3rd power. For the next part, we bring down our sign and we multiply 2 to our coefficient, giving us 12x. And of course, 2 minus 1 is 2, leaving our second part 2x. 12x. Pardon me. For our next part, we have 10x, which leaves 10 by itself. And then anything to the 0 power is 0, leaving us with 12x cubed plus 12x plus 10 as our derivative.
So here we have a very strange problem. It has sine, cosine, and 1 over x. Here we're going to talk about the derivatives of sine and cosine. The derivative for sine of x is cosine of x. But they're not the same, because if you look at cosine, the derivative of cosine x is negative sine. So in order to do this problem, you would have to know that sine's derivative is cosine, and cosine's derivative is negative sine. And when we look at 1 over x, the derivative for 1 over x is actually ln. So when we do this problem, we're going to see that sine becomes cosine, and cosine becomes negative sine, and then we're going to see that 1 over x becomes ln. So this would be our derivative.
With derivatives also comes antiderivatives, where you're kind of reversing the process that we just explained or finding the original equation. So in this example, we're going to break it down into our 3 functions. So for 4x to the 7th power, in this instance, we're going to add 1 to our exponent, and whatever that is, which is 8, we will divide underneath our thing, which comes to 4x to the 8th divided by 8, and it cancels out, So it rounds to 1/2 x to the 8th. For 3x squared, we repeat the same process. So we add 1 and divide by 3, which gives us 3x cubed divided by 3. Our 3's cancel out, and that gives us x cubed. And again, we bring down our sign. For the last one, it's just a 2, and because we're reversing it, we will be adding the variable x to the equation, which gives us 1/2 x to the 8th power plus x squared plus 2x is our antiderivative.
Woo! We passed! Thanks to Maya and Susie, we learned derivatives, and we were able to pass calculus.